It's my great pleasure to introduce Susanna Brady, who is the Senior VP of Marketing and Sales for Cobalt Digital. And she also is the chair of the RIST Forum and is acting as our host for today's webinar. Take it away, Susanna.
Okay, thank you, Wes. First of all, good morning, good afternoon to everyone. Thanks for joining us today. I'd like to thank Wes Simpson for agreeing to moderate the session, and I also would like to thank our panelists for volunteering their time to be today here with us. We've been asked a few times in the past few months to have the RIST Forum members, which includes vendors, end users, and service providers from all over the world to share real-life deployments and lessons learned. So here we are today. For some of the attendees who might be new to RIST and to the RIST Forum, the RIST protocol has been around for a couple of years now, and we have over 150 very active members. During that time, RIST has been implemented in a wide range of video products and solutions, and it has been deployed for a variety of use cases around the world. So we decided to put together this quick roundtable to share a little bit of some of the real life applications, to report on what we've done, how we've used RIST, challenges that our members have faced, and pretty much what we've learned in the process. So with that, I will introduce today's moderator, Wes Simpson. He's the author of 2 books on video over IP, among many other wonderful things, and also the founder of learnipvideo.com. So check it out. With us today, as part of our panel, we have Rick Ackermans, who is the Director of RF and Transmissions Engineering for CBS, Operations and Engineering Group. We have Dr. Sergio Amirata, who is the Chief Scientist at Sept Radios Group. We have Dr. Cyril Narayan, who is the Executive Vice President of Engineering at Cobalt Digital, and also he's the President of the RIST Forum. Mr. Adi Rosenberg is the CTO and founder at VideoFlow. And Doug Shelton heads pre-sales engineering for the Americas and Net Insight. So dear, special, unique panelists, thank you so much for being here with us. With that, I will leave it up to Wes. Wes is going to go over which applications we're going to cover, and we're going to get started. Thank you very much.
Thank you, Susanna. And that was a great introduction. So today we're going to cover 5 different application areas in various depth. We're going to start out with studio to transmitter links, both STL and STLTP. We're going to talk about network distribution. We're going to talk about contribution video. We're going to talk about remote production and monitoring. And we're going to talk about cloud contribution. So to kick us off, we have Rick Ackermans, who's going to tell us why broadcasters need this technology. Rick, over to you.
Hello, thank you, everybody. Welcome. So today I'm going to talk about some generic applications. None of these are specifically being implemented by any entity. I'll put that disclaimer in there. But what we're looking about is contribution and distribution. So a lot of us are familiar with standard point-to-point distribution with work. Point-to-point with RIST. We use it all the time. We use it for news gathering. We use it for conferences. So where you have a source, you take it, you compress it down, or to get the data rates to manageable. You go off to the ever popular internet, across the internet to a receiver, and then to your display, your endpoint, your station, your network, whoever it is you're ultimately sending it to. So that's your typical point-to-point. To put it into a geographic perspective, it would be something more along the lines of this. Yes, pardon this being a sort of New York-centric origination point. It could go the other way. It could go from any point to any point. But this is just sort of the same sort of thing I showed when displayed over a geographic area. Simple, point to point. In this case, it's a studio to transmitter receiving the feed. But what happens if you want to do distribution? Distribution is just not one point. It's often multiple points. Where you could start with this same concept, but since you're going to the cloud, we are working on RIST Cloud, and there are applications out there in development going on within RIST to support RIST in the cloud. And you could go to multiple points. In this case, I showed 2. It could be 2, it could be 200, it could be 2,000. Doesn't really matter. But what if you needed redundancy? If something goes wrong with your link, what happens if you have a fiber cut, internet congestion? Well, RIST allows you to use multiple different data centers, different ways to get from point A to point B to point C, giving you redundancy. Centers 1 and 2 would be diverse. Data centers would have to be RIST enabled. You could use diverse ISPs to avoid any single point of failure. You can also do load balancing, so you're not totally doubling up on your data. So you're load balancing at 50%. If a data center goes down, it could easily default over the other data center, potentially totally lossless without any kind of hit. And if a packet gets dropped, it can be sent from the other data center, giving you total redundancy for your network distribution, which for some entities and people who work for large broadcasters or place where a lost packet has lost money, this might be very important. Might also be important to retaining one's job. So on a geographic level, you'd have something like this. You'd have various cloud data centers, various receive sites, transmitters if you want it to be. It could be anything. I'm just showing transmitters. It could be cable head ends. It could be business offices. It could be whatever you need it to be. And you have your primary distribution that way across the network. But as I said, what happens if you need redundancy? Well, you just add an additional layer, as I showed in the previous slide, and you can have complete and total redundancy across multiple data centers, delivering a network, a stream, or a product to multiple locations. Now, this actually ties into just about everything RIST has. I'm not going to get into the nuts and bolts. There's plenty of other people who can get into exactly how it works and the mathematics and the data and the flows and all the fun IT stuff we get to deal with every day. This is just a user's concept of how RIST could be used for either point-to-point or point-to-multipoint. Obviously, I'm only showing a handful of receive sites here, just because if I put in a typical broadcast, US broadcast network, we have about 200 plus affiliates. This screen would just be one giant blur and you wouldn't be able to see anything. So I'm just putting in a subset so that you can actually see the concept of what's going on.
Rick, thank you.
This is just an overview. I will hand it back to Wes, and he can have some of our other fine panelists get into many of the nuts and bolts.
All right, Rick, thank you very much. Now we're going to have Adi Rosenberg from VideoFlow give us some information about microwave applications for RIST technology. Take it away, Adi.
Thank you, Wes. So, as Rick pointed out, he shows an STL, studio to transmitter link, and now with the emergence of Gen TV that we're going to touch base later on also, the RIST is a perfect conduit to deliver STLTP. STLTP is an IP protocol that is carried over microwave. So just in the same way that Rick showed the distribution that you can do load share of 50-50, we can do now the same thing with the STLTP. We can take a feed from a studio, deliver 50% over a microwave, another feed of 50% over network, which can be internet, leased line, private cable, or another microwave. And we can then reaggregate that on the receiving end, so it's seamlessly aggregated and delivered to the exciter. So now it becomes a very fault-tolerant solution to allow the reliable delivery of the content. What RIST adds on top of the standard STL-TP is the security, the secure layer of reliable delivery and free of intervention or inspection by any third party. So then you know that when you're going through a not protected line, you are fully protected by way of the RIST tunnel that can be with DTLS or PSK encryption.
Thanks, Adi.
Take it away.
I just wanted to ask a quick question.
Sure.
In your example here, you're showing STL-TP. Would this work for traditional STL links as well?
Well, it can also work with STL. Traditional STL is usually, it takes ASI over the microwave. So one can do the same thing, but the switching on the receiving end will not be seamless. There are ways to do that also seamlessly, but then it is done in the transport layer, and you can create a seamless type of apparatus to control to have a seamless switching on the receiving end and give it the same capability. Yeah.
Great. Thanks for that, Adi.
You're welcome.
And we're going to switch over now to Doug Shelton. And Doug's going to talk about central casting. And then, as I understand it, Doug, this is a live application that's already up and running in one of your customer sites. Is that correct?
That's absolutely correct, Wes. And as Adi touched on, RIST is a very versatile protocol, right? It works with STL-TP, which is the ATSC3 next-gen TV transmitter link standard, but it also works equally well with the previous generation ATSC1 standard. We have a long-standing relationship with Sinclair Broadcast Group. They're one of the largest station group owners in the United States. And they had been using RIST and some previous protocols for links between their studios and their transmitters, and also to the translator stations, which are repeaters that fill in television signals in areas that normally otherwise wouldn't receive them. They're very common in the Western US, in Alaska, and places like that. They came to us with the challenge of being able to go from a traditional, as Adi said, ASI-based or MPEG transport stream-based studio to transmitter link to a new, pretty much highly developed protocol for ATSC3 called STL-TP. One of the things that's critical about STL-TP is that it actively uses information in the RTP header to provide timing information to from what's called the scheduler, which is the final multiplexer that feeds the transmitter, and then deliver that along with forward error correction to the transmitter itself. FEC is typical row column FEC. It might work well in a well-controlled environment. What this customer had found is that there are some sections, whether they be microwave-induced errors, whether they be errors within a corporate network infrastructure that's shared with other traffic, or the internet itself, FEC was simply not enough. However, a lot of legacy protocols, not RIST, but legacy protocols were built around MPEG transport streams, and they wouldn't accept the STL-TP protocol. So we made some enhancements using RIST and adapted RIST specifically to the challenge. And so today we are using RIST on the air with Sinclair between Dayton, Ohio and Buffalo, New York. They're expanding it. But the real thing is that RIST brings, as Adi said, and as I will emphasize, RIST brings encryption. RIST brings a much more robust error protection mechanism and error recovery mechanism. And yet it also allows transparent transport of the critical pieces of information that are necessary to establish the proper relationship between an ATSC3 studio scheduler and the exciter, the transmitter that's going to bring next-gen TV. So back to you, Wes.
So if my geography is correct, Dayton, Ohio to Buffalo, New York would be pretty much impossible using traditional microwave hops.
Oh yeah, no, this is not a microwave application in any sense of the word, because it's not that the studio is local to the transmitter. This is kind of a hybrid between a traditional link that goes from a studio in a city to a transmitter up on top of a hill, and the kind of distribution that Rick was talking about, where you take a single signal and move it out to a number of different transmitters. The central cast model is a model that a number of broadcasters are using to achieve economies of scale, where they put complexities of running multiple local TV stations in a single facility, and then feed the transmitters in the individual cities from that facility.
Great.
And so, yeah, this is not a microwave link. There may still be a microwave link somewhere in here, but RIST is passing from the exciter all the way to the transmitter across any number of different kinds of links.
Great. Well, thanks for that, Doug. Next up, we want to talk about network distribution. And for that, we're going to switch back to Rick Ackermans, who's going to be talking about how to serve MVPDs off of satellite, and also a little bit about collection networks. So go ahead, Rick.
This particular image, as I showed, in traditional transmitters, but once again, it could be MVPDs. Now, MVPDs, you do have the issue that you may have redistribution. For example, if you hit not to mention any names, but somebody like Comcast, where everything goes to Denver or Philly first, or here in Atlanta, where I am at the moment, they can have their own distribution network. But if you're feeding MVPDs, it's a very similar situation to what you had here with your STLs, only you're either hitting mega head ends or you're hitting many, many, many smaller head ends. So the model still holds. I could show it on this chart, but once again, you'd see nothing but a giant red and green blur. So that's, what you have to do if you're trying to get to those. Now, that was the MVPDs. Pardon me, Wes, you mentioned something besides MVPDs. What was the other part of that?
Well, moving off of satellites.
Oh, once again, as Adi showed microwave, these two paths don't necessarily have to be both terrestrial. You could have a satellite and a terrestrial mixed in. So half of these clouds could really be up in the cloud, the real clouds, above the clouds. The other issue you have is with a distribution network like this, it's much easier using the data centers to hit many, many locations. The number of receive sites for MVPDs has dropped as they've gone to the super head ends. Many years ago, there were up to 30,000 receive sites you had to hit in the United States if you were hitting MVPDs, because every community, every small town had its own Earth station. So even in an area like Metro Atlanta, at one point, I remember when here in Metro Atlanta, we had 18 different downlink sites.
Wow.
So obviously satellite was a very practical way to do that. The internet also works. Luckily, you don't have as many receive sites for hitting MVPDs as you used to. But once again, with a cloud to end user model, something like such as this works. Just in this particular case, instead of feeding the transmitter shown by the tower logo, think of it as the dish or cable TV system logo.
Well, great. Thanks, Rick. Yeah, I've noticed the great reduction in Earth stations going on throughout the cable industry. That trend has been going on for 25 years now, and it will continue, I'm sure. So thanks for that. Next, we'd like to move on to talk about some contribution applications. It's no good having a great distribution network if you don't have the ability to bring your content into your production facility and generate the programming that you want folks to watch. So we're going to start out with Adi Rosenberg talking about a very unique 5G mobile telephone-based system that has been used for contribution successfully. So take it away, Adi.
Oh, thank you, Wes. So just like Rick showed before, the ability to send on multiple paths, now we see the exciting new medium, which is the 5G. We can now supplement any delivery system which is using RIST with the 5G and use that as another medium to utilize to do a diverse path streaming over 5G and internet or this line. To that, we can also add the LEO, the low Earth orbit solutions that are common now in the US. If you can accommodate the delay, that brings a very low delay application to bear to customers. This is something that we demonstrated a few months back from Australia at the last VSF session. And this is something that many new customers of ours are starting to embrace as a backup, because 5G is still too high, is not that available, but in any place that it is available, you can utilize it as a primary or a backup, and you can do a load share with the 5G to deliver that to the receive side. And now you have another means that you don't need to put a cable or ask for a microwave to be available on site. You just bring your modem, plug it into a device that can give you 5G, and that's it. You can be up and running in a heartbeat.
Adi, do you have any comments on the economics of using 5G for contribution? Is it economical to do that today?
Well, Mike, yes, I can say we have clients that pay a few $100 a month to utilize 5G. Most of the time, they will not use it as for a full streaming, but rather use it for 10% of traffic or only the error recovery. But it can burst and go to a full load at any time if the main link is suffering for problems. I can tell you that we have houses of worship that using that for their Sunday distribution. Basically, it's a contribution for their set of operation, and then they distribute it to the cloud and then forward. So it's quite economical. It doesn't take too much money. And if it's available, it's there to be used efficiently. Is very nicely. The RIST doesn't see it as anything other than a regular network device, and that's it.
Yeah, thank you, Adi. That's great. Really appreciate it. Let's switch over to Sergio Amarata, who's going to talk about an application of RIST that he's helped install that's being used for producing content in a COVID environment where you have people distributed across a large geographic area. Take it away, Sergio.
All right, so let's talk about the application of TV studio production, remote production, not necessarily the stream that's going to go live, but the stream that's going to help producers and directors create the content itself. That's what we did for our customers, basically. They are trying to produce new content in the COVID era, where you have people that cannot travel. So you set up a minimal crew on a remote city, and then you need the producers, directors, engineers to receive those streams in real time or near real time. And that's what RIST allowed us to do. How do you receive high quality, secure, and near real time stream on a remote location? Basically, this is the diagram shows, the remote locations that have the cameras and the libris encapsulator. The encoder and also MPEG-TS goes in, and it goes through the RIST tunnel to in this particular case, an AWS cloud, where all we do is we grab those RIST streams and turn them around and turn them into WebRTC to be displayed on a web browser on the remote producers, directors, engineers that are participating in the production of such TV show. The steps, like I mentioned, you have USDI sources. This happens actually for these customers through many locations, many cities, and they all have the centralized method of distribution of the production of the shows. We have encoders on each location. They produce MPEG-TS. We have a built-in gateway into our units that grabs the MPEG-TS, encapsulated in RIST, and sends it to AWS. On AWS, we have our own images, our own OS that can receive the RIST, take out the MPEG-TS, and turn that into a WebRTC stream, where we put our own layer of security on top of it in the WebRTC, which already has some, for the immediate remote viewing. So
That's great. So Sergio, quick question. Why RTC at the end? Is that just to have maximum compatibility with the various director and producer devices?
Correct. We started actually, this project started libris or RIST to RIST all the way to the end user, even producers, directors. And we found that to get the RIST streams to the miscellaneous people was difficult because the player required to be something custom, either a hardware device or a software device that needs to be installed. So this migrated slowly and surely to give me something that can run on a web browser with no installation whatsoever.
Gotcha.
Something that somebody can log in with their SSO like they do now, and boom, they have the video, high quality, low latency, and secure, because it's WebRTC also gives you a layer of encryption.
Great, great. Well, that makes a lot of sense. Thanks for sharing that with us. And now we're going to switch over to Ciro Noronia, who is going to be talking us through a seamless redundancy application that he's installed at a customer site. Go ahead, Ciro.
Yes, thank you. So this is an actual customer installation. I'm just not going to say the name because I don't have permission, but the objective of this customer was to have very high reliability. And what they had is a corporate LAN among the sites with lease lines. So they had dedicated lease lines through a provider between the sites. They also had internet on every site just by default. So they asked us for a means to transmit, but using both of them. In their minds, the corporate lease line is the primary and the internet is the backup. But they don't care that it's transmitting all the time. So instead of doing a load share 50-50 or something like that, we did 100% of the signal on both, 2 copies essentially on both, on each of the links. And we use traditional Sept 2022-6 seamless redundancy, which is actually -7, sorry, got it wrong. But it's part of RIST. So the receiver gets 2 copies of the stream and uses most packets you're going to get 2 copies of, and use whatever packet you get. And if there's packet loss on one link, maybe there isn't in the other, and we just use it. But the packet loss is compensated. So if one of the links goes down completely, the other is still there. There's no glitch. And if there's extra packet loss or anything, you have the other link in parallel. In this particular case, this customer did not care very much about the security. They didn't care that the stream over the internet was in the clear. We offered them the ability to encrypt, and they said, no, it's not necessary. It's stuff that's going to go on there anyway, and they're going to get it for free, so they didn't care. Mm-hmm. But they deployed multiple versions, multiple links like that, and that's running today.
So Sarah, can you give us any feel for the delivered reliability? Are you getting? Do you have any long-term numbers on how the 2 networks are performing?
I don't have any long-term numbers.
Okay.
But I know that since commissioning, this hasn't gone down, and they haven't complained of anything. So the equipment does pull statistics, and I show them how to do that, but they haven't shared that with me.
Okay. Well, thank you very much. I'm sure that the numbers are great. And don't go away, Sarah, because you're up next to talk about remote production and monitoring and a kind of a neat remote multiviewer application that you've put together.
Yes, this is yet another customer. The customer wanted to do some remote monitoring, and they use the Multiviewer. So a Multiviewer is used to combine multiple feeds, do like a video screen with multiple pips, but they wanted to see that on the other side, not where those signals were generated, but on the other side. So the output of the Multiviewer is a standard SDI screen, just like we did all the RIST demos on the various trade shows. Remember when we had trade shows, that thing? So what we provided to this customer is the ability to just transmit that over the internet. So it is a very typical, very simple RIST application, but what it's carrying is multiple videos combined in a multiviewer. And in this particular case, it's not really a RIST specific thing, but the customer wanted multiple audio, wanted surround, wanted all of that. And we combine all of that into one stream and send it through RIST. In this case, one single link over the internet, they did not need the absolute reliability over the previous application I showed you.
Mm-hmm.
And we all know that the internet drops packets, and sometimes there is very high loss. RIST can compensate by increasing the latency. This particular customer did not care for that, and they accept that they will take some hits, and they have taken some hits. But since it's just play monitoring, they don't care.
Well, great. Again, on this particular customer, how widely have they deployed it?
They have a large number of links. It's not a very large, it's not in the hundreds, but it's a few links. But when you use the multiviewer here, you're taking one stream that has multiple videos in it on the video side, so you don't need many of these. Great.
Well, thanks for that. Now we're going to switch back to Sergio, and keeping it with our theme about Sergio Amarato, keeping with our theme about remote production and monitoring. And Sergio is going to be talking about how RIST can be applied to control a PTZ security camera. So being able to pan, tilt, and zoom the remote device. Go ahead, Sergio.
All right. So this particular application was for the transmission and control of PTC across the internet, across a RIST link. So the idea is pretty simple. You have a camera that transmits transport stream or any other method that is transmissible over UDP. And there's also a protocol to control the camera, to zoom, to tilt, to move the camera around. But the camera had a custom software. It wasn't necessarily a standard protocol. So we needed a way to have a remote location control the camera. And this is what was used. We have, again, an encoder that a RIST gateway, not an encoder, that grabs that camera, encapsulated in RIST, but RIST has a feature also we can transmit all the data, any other data, not necessarily through the packet recovery mechanism. In the case of the libris library, which is what we were using, we use a new feature called the TON adapter available. And what this does is that we perform the packet recovery over the regular video, but the transmission protocol, the software communication, it acts almost like a transparent tunnel between the remote device and the software running on the machine. And in this particular case, the software that controls the camera also has, that same machine has the software that runs the libris receiving end. So basically we create a tunnel for the protocol and the RIST video with the packet recovery. And just like we did with this PTC protocol, this can be extended to other different devices. Perhaps you have to control something else behind that other network. It's not a PTC camera, it's some audio switcher or some other device. You can do it through this method. And you don't need a separate tunnel to do it. Thank you.
Yeah, and Sergio, just correct me if I'm wrong. This is kind of a unique feature for RIST, right? Most of the other reliable streaming protocols that are out there don't really support this arbitrary tunnel capability. Is that correct?
That's correct. We made it a point to enhance the protocol in such a way that this type of application was possible, early in our designs, so that you don't have to have a tunneling application and a transport application for RIST. This can do both in one.
Great. So let's finish up this category and have Adi Rosenberg talk about other non-standard protocols that he has managed to get through a RIST environment and to great success, I believe. Go ahead, Adi.
Can you hear me? Okay. So yeah, So just like Sergio said, when the RIST advanced tunnel, the RIST tunnel was designed, it was meant to deliver any type of data bidirectionally. It's not a tunnel per stream, but rather the ability to send bidirectional traffic. You can send a stream, you can send audio, you can send HTTP, SNMP, whatever works for you, you can set it up. In this example, a video flow device, which acts as a gateway, shows the same application that Sergio showed before, in which we also utilize the 5G and the internet for the connectivity. But here we have an external PTZ controller that uses the tunnel to control the camera, also provide teleprompter information. And this is a moving target, meaning that the transmitter is a client which can move from location to location. Each time he comes to a location, all he does, connects to the internet, pulls up his 5G, brings power on, and boom, he is connected to the receiver side where the server exists, and he can commence transmission, just like a backpack will do. Now, the RIST tunnel can move any IP data, anything that you can imagine. You can run high bit rates, low bit rates, SSH, whatever you do. But for those who are scared because of security, RIST also gives you the security. It can provide you a firewall on that tunnel device, on that GRE tunnel that Sergio just mentioned, and it can block away unwanted traffic. So if you don't want to get unwanted traffic that you don't know or you're not familiar with, you can block it at the RIST GRE tunnel, so you are secure and your IT people are very happy with that. VideoFlow has been using this RIST tunnel from the day one, or it's like 2 years now. It's also very good for redundancies application, meaning that switching between clients and that you can change and swap. We do have an application with Cobalt, which we are doing that to a particular customer. We have a Cobalt encoder, and if we need to switch to another encoder, we just switch between tunnels and that's it. So that is the benefit of using RIST. From the day one, it was designed to be a professional solution to achieve these goals.
So Adi, can you give us a little insight as to what the customer's mobile application is, or what kinds of content are they moving over it?
The content here can be news. We have betting, which needs low delay to get to the other end, and RIST is a perfect conduit for that. Those are sub 100 milliseconds delays, which is perfect for betting, but also perfect for news gathering and so on. Now, on the receiver side, you can then bring that to the cloud, to any location that you want, pre-production or distribution, like in Rick's example before.
Great. Well, sticking with that cloud theme, we're moving on to our final category here. And Adi, you wanted to talk about a libris application for contributing signals to the AWS and Google applications. So
yeah,
take it away.
Unfortunately, I don't have a slide, but we have Sergio, who is the father of libris. We have many clients coming to us asking us to provide a gateway at the AWS or Google/Alibaba clouds. So they will use their libris to gain access to those clouds. So it's a perfect example how an open source solution used by a customer can gain to the cloud. There's a gateway there, just like Sergio showed in his solution, but a gateway by VideoFlow. I know of AWS offering Media Connect solution that also offers RIST. So that is a perfect example how RIST can be used today for real-time application to get to the cloud, from the cloud, and create new type of application that we can just imagine or envision that were not there a few years back. You need to have proprietary protocols, and now the door is open for new type of applications.
Wes, I was going to suggest that maybe Sergio can explain what libris is, because we
mentioned a great idea
times here and we haven't gone through what exactly that means.
All right. Libris is an open source implementation of the RIST protocol. It's licensed as a BSD type 2, which is one of the most liberal open source licenses out there. It encourages commercial use. Anybody can grab it, use it in their products. They can contribute back to the open source community if they want to, but they're not required to do so. So it's there for anybody that wants to immediately use RIST into their product without doing any development or minimal development. We have not only the library, but we have command line tools that allow you to just run them side by side with your software. And then that will give you time to do more deep integration into whatever workflow you had. But you can just grab a local MPEG transport stream on your network with our tools and push it to your own product or to a remote location. And I know of several large companies that are actually using the libris library under the hood, and we find they actually label it as their own RIST implementation. It doesn't matter. There are no restrictions, no limitations. You can do that as well.
So Sergio, if you get a chance, could you pop the URL for the libris into the chat so everybody can see it?
I will do that. Yes, absolutely.
Great. And let's finish up our talk about cloud contribution with Doug Shelton talking about an absolutely amazing multi-tenant contribution distribution system using the cloud. Take it away, Doug.
Thanks, Wes. So really, we've heard some great topics and some great points about the versatility of RIST from Rick, who early on alluded to RIST in the cloud and how that is a coming thing. How Sergio talked about the flexibility of using RIST to get traffic into the cloud and then transform it into, in his case, WebRTC. In order to make it more versatile. So it shows that the cloud can be a place to have transformative joining of disparate types of traffic. And RIST is a way to enable that. We've heard a couple of different references to the power of the tunneling capabilities that RIST brings to the connection from a remote site to another site or to the cloud itself. What's changing now, and what we've worked with a couple of our customers, one of whom is the Switch and has allowed us to use their name as part of this use case, is the challenge of going from traditional dedicated media networks, leased lines, specialized equipment, and moving towards internet delivery, but not just internet delivery, moving to cloud-based aggregation, replication, distribution, and contribution of media. And to do all of that with the same level of control and visibility that you would get out of yesterday's dedicated networks, but with the flexibility and ubiquity of IP delivery. And so what we've done and what we worked with this customer to do is leverage all of the features of RIST along with cloud computing to put together a global infrastructure that can be deployed not just in one cloud, but in any cloud environment. We are working today with customers in everything from Oracle Cloud to AWS to Microsoft Azure to Alibaba. And by leveraging RIST and the ability to deploy RIST across a variety of connections, along with leading edge cloud-based technology like Kubernetes and Grafana and tools that are built for making the kinds of distributed infrastructures that are out there, our customers, including the Switch, have been able to deploy a true global infrastructure. The map you're seeing here is not their map. Their map actually would be much more diverse because they and some of our other customers are leveraging and building out today the kind of architecture that Rick showed earlier, where you have multiple data centers, where you have RIST feeding RIST reflectors or distributors in the cloud at multiple data centers so that the source can be built using either 2022-7 to the destination, but we're actually going beyond that and being able to do some things like 1+1 failover, go only from a primary, go only from a secondary, take from both use RIST to try to clean, and if RIST can't clean up both connections, then do a -7 merge. This brings reliability, but it also brings the ability to do things like upgrade the cloud environment by upgrading one side of the cloud while the other side still delivers the signal reliably. That's the sort of thing that is going on here. We couldn't do that without RIST. RIST is the glue between the cloud instances that make up the switch infrastructure, as well as the others who are using Nimbra Edge. One of the really cool things about it is that it does allow us to eliminate a lot of third-party firewall considerations. And this isn't something that I've heard a lot of talk about. It was alluded to in a couple of Adi's slides. But one of the powerful things about RIST compared to other protocols, especially some earlier ones, is that the RIST tunnel can be originated inside a customer firewall using only a single UDP port and establish a connection to the far end, in this case, the cloud. Once the tunnel is established, inside that tunnel, flows can go in either direction. So it minimizes the need for end customers to have to open up their firewall for inbound traffic. And it allows very clear and easy deployment across a DMZ or across a controlled internal to external network environment. This particular application, Nimbra Edge powering the Switch's Mimic offering, is on the air live today. They have been using it to deliver Tier 1 sporting events. So the kinds of things that we've talked about, the encryption, the reliability, the cloud's ability to ingest and distribute, all of those things are wrapped in, all of those things are powered by RIST. And we have live customers today who are leveraging that power. Questions?
Doug, thank you. Thanks for that. It certainly drives home the point as to how essential RIST type technology is for this kind of an infrastructure. So thank you so much. It really is the key to unlocking all these different applications. And
Yes,
and obviously we're going to keep working on the RIST protocol to add some relay capabilities and things like that. So we encourage people to stay tuned. Just wanted to switch back quick to Susanna, who wanted to update us on a couple of more events that are coming up in the near future, and give us a nice little way to wrap up our talk for today. So
sure.
Over to you, Susanna.
Thank you, Wes. I just wanted to ask if anybody in the audience has any questions to any of our panelists, since we're all here. We're all here for you. And so if you, while I'm making a final announcement, if you want to pop in any questions on Q&A, or if you want to raise your hand, whatever you want to do, let us know. I'll be happy to answer your question. I just wanted to mention that in the next 2 weeks, 2 weeks from now, we're going to have 2 significant industry events offering some very interesting sessions on RIST implementations. The Video Services Forum, the vsf.org website, they'll be having their fall meeting series event, which will take place on September 22nd. There'll be 2 sessions featuring RIST. So one is the PBS Kids Go Live in Australia directly from the US. There's a session on RIST, my PTZ security camera, and there's a session on timing and IP production on the ground and in the cloud. So that one is actually delivered by Wes Simpson and Dr. Cyril Narayan here on the session today. The next day, September 23rd, there's another major industry event, the Sports Video Group's annual Transport virtual conference, and they're going to be featuring a session on all those different protocols used for transmission over the public internet. So there'll be representative from RIST and ZXI and SRT and more. So it's going to be a very good session for you to take a moment to tune in. So you can register for both events, again, September 22nd and 23rd. And we're looking forward to seeing some of you on one of those sessions. And that's about it, Wes. I'd like to thank the panelists for their time and their preparation. This is all fantastic. There's plenty more that we couldn't fit in today, so hopefully we're going to have another session like this soon. And we know that many people who register ask for the recording of this session, so we always provide that, and we always publish this on the RIST Forum YouTube channel. So look for the session there in the next couple of days, and it should be published. And thank you so much, Wes. Go ahead.
Thank you, Susanna. Thanks to all of our panelists. Again, we had Adi Rosenberg from VideoFlow. We had Rick Ackermans from CBS Operations and Technology. We have Sergio Amarata from SIP Radius, Doug Shelton from Net Insight, of course, Susanna Brady from Cobalt, as it says brilliantly over your head. And we have Ciro Noronha also from Cobalt Digital. So thanks to all our panelists, thanks to our attendees, and we look forward to seeing you virtually or in person in the near future. Thank you so much.
Thanks,
Take care,
everyone.
everybody.
Thank you all.
Take care.
And I'm also going to talk about RIST at the VSF, if somebody wants to hear.
That's great, Adi. Thank you so much. Take care, everybody.